In our time studying chemistry, we've come across a whole range of types of reactions. For example, acid-base or neutralization reactions, combination, where we're putting two elements together and making a new compound, or precipitation reactions. Another class, which also includes some of those ones I've mentioned, is the oxidation reduction or redox reactions. We say the two words oxidation and reduction together because they're what we call complementary reactions. When one occurs, the other must happen to something else. What makes oxidation reduction or redox reactions special is they are when electrons are being transferred between different substances. This electron transfer is what we're looking for when we decide if a reaction is redox or not. One example of a redox reaction can be shown when zinc is placed into copper sulfate solution. So if I have a beaker with blue copper sulfate solution in it, and then I put a piece of silver zinc in it, we end up noticing that there is a change in the zinc and in the solution. What happens is the solution goes a really pale blue colour, so it loses a lot of its colour, and the piece of zinc starts to get a bit of a reddy brown tinge to it, particularly on the edges, and the zinc starts to be eaten away. So we get this reddy brown colour. Well, knowing a fair bit about our different substances, we know that the reddy brown colour is indicative of it being copper metal, or just Cu. So that means that, in the paler blue colour, tells us that some of the copper ions must be being used up. That's our inference. So some of this copper sulfate solution, which is Cu2 plus ions, but we'll put copper sulfate solution in there, some of that is being used up to make copper metal. We also notice the zinc starts to break apart. So some of our zinc metal, which we started with here, is probably becoming zinc ions. So you'd say that if we left it long enough, this would become colourless and go from being a copper sulfate solution to being a zinc sulfate solution. I'm going to put copper in there as well though, because it actually would still have copper, otherwise it wouldn't have that pale blue colour. So what we're looking for is what is actually happening. Well, if we have a look at the chemicals we started with zinc, and the zinc was turned into zinc ions. That's why it started to break apart. We also started with copper 2 plus ions from the copper sulfate, and these became copper metal, some of them anyway. Well, while these look like balanced equations, they're not balanced for their charge. So the elements are balanced, but not the charge. For the zinc to become 2 plus, it can't gain protons. That would make it a different element. So it must be losing a negative charge. So it must be losing electrons. And because it's a 2 plus charge being formed, it's 2 electrons being lost. Therefore, because it's being lost, we say that it's being oxidized. So it's an oxidation reaction. That means that the reaction of copper must be a reduction reaction, because you can only have one with the other. Oxidation can only occur when reduction occurs. And we see that for the copper 2 plus to go down in charge to Cu, it must lose 2 electrons. So we can see that those electrons are being transferred, and that's what a redox reaction is. Now, one more thing just very important that you need to note is that the loss of electrons from the zinc to the copper causes the reduction to occur. So we call the zinc a reducing agent or a reductant. At the same time, this could only happen if the copper 2 plus could accept those electrons. So the copper 2 plus ions are causing the oxidation of zinc. So we call the copper 2 plus the oxidant, Or you could actually say that the copper sulfate is the oxidant. So copper 2+ is our oxidant and zinc is our reductant. So there's some other definitions that we do need to know in learning this background about oxidation reduction. So just to say it again, oxidation reduction is a reaction type where we've got electrons being transferred. If oxidation is occurring, so must reduction be occurring. We can see that by the transfer of electrons in these little what we call half equations. And the thing that causes reduction to occur is called the reductant, so in this case zinc. The thing that causes oxidation to occur is called the oxidant. In this case, that is copper 2+.